So, I want to tell you guys a story. The first robot I ever built didn't work. It wasn't dramatic or like in the cinematic way where there's like sparks or smoke. It was worse. There was just nothing. I pressed the power button multiple times and just the whole machine just sat there like a brick. And I had spent weeks preparing for it. I just stared at it and I thought, I followed every instruction. I triple checked the diagram and I didn't skip a single step. But robots don't care how carefully you read the manual. It doesn't care how confident you will feel when you flip the switch. It only responds to what actually is. After hours of denial, I finally found it. One loose wire, barely visible. A connection so small that if you were looking for it, you would never find it. This tiny failure shut down the entire system. That moment taught me my first real lesson in systems. When when even one part fails, no matter how small or invisible, the whole system doesn't work. The whole system will stop. At the time, I thought this lesson was only about robots. I was very wrong. Before seventh grade, I had lived in Houston very much my entire life. It was a really stable system. It was the same city. With the heat was unbearable, but I was used to it. And I was in the same school since kindergarten. It was the same group of friends I'd known since we were all still learning how to tie our shoes. I knew exactly who I was supposed to be. I knew my goals, and I knew what I was good at, math and science. And I lived inside that single comfort zone, like it would, like, and I had no idea what was outside. I didn't question it that much, and I didn't feel the need to reach out. I wasn't really shy or antisocial, but I genuinely didn't have to. The system was optimized. Everything ran smoothly because nothing ever changed. And but there's a quite danger of systems like that. They're really efficient, but also really fragile as well. As well, they only work as long as the environment stays exactly the same. And environments never actually stay the same. In seventh grade, my entire environment changed. My family moved from the hot weather of Houston to the freezing cold of Newfoundland, Canada, for my dad's job. We traded 100-degree summers for winters where the cold didn't just bite, it numbed your face in seconds, made your eyes water, and forced you to question every life choice that led you there, as I did many times. But the weather was the easy part. The school there was unrecognizable. It wasn't the math and science that I grew up with. In their place, it was project-based learning, endless groups discussions, and essays that demanded your actual voice instead of just a repeated essay that you just changed to make it fit the criteria. And you had to make presentations in front of the whole class. And art classes, where creativity wasn't optional, it was graded. These were all things I had quietly avoided my entire life without ever admitting it to myself, really. And socially, it was quite brutal. I had never learned how to walk up to a group of strangers and introduce myself, mainly because I stayed with the same people all the time. I didn't know how to rebuild my social circle, and I sat at lunches feeling invisible and watching everyone else already have their systems full. I wasn't quite broken. I was just simply running on hardware that no longer matched the world. That same year, I forced myself to join the robotics club, even though everything in me was screaming not to. I had quite loved robotics from a distance, from a pretty young age, but I was quite terrified of committing. I was terrified of failing in front of other people, terrified of letting my team down, terrified if that I didn't win, it would prove that I didn't belong. But robotics didn't really negotiate with fear. You design something, you build it, and you test it. It fails, usually a lot. And then instead of spiraling into self judgment, you sit down and ask better questions. Why didn't it work? What exactly didn't work? What assumption did we make that turned out to be wrong? Through that process with my team, I learned something. Failure isn't a verdict on who you are, it's just data, and we fail consistently. So we take that data and use it to better ourselves. Every single failure gives us information that we didn't have before. Every iteration, every rebuild, every line of code rewritten makes the system stronger, more resilient, and more capable. Eventually, after months of this, we placed third in our province at the first Lego League provincial competition. The trophy was nice, but the real victory was realizing persistence isn't about pushing harder with the same broken approach. It's just about adjusting smarter, about listening to what the system is actually telling you. Another lesson hit me more slowly over many late nights. No systems function in isolation. A robot is only as good as the integration of its hardware, its software, its mechanical design, but all of those only exist because of people. I had to learn how to explain my thinking clearly, even when was sure I was right. I had to learn how to listen, really listen, when someone disagreed, not just wait for my turn to speak. I had to be willing to throw away my favorite idea when the team's testing showed it was wrong. Without me even noticing, my communication skills got sharper. My writing improved because I had to document our designs for the judges. My confidence grew, not because I became some outgoing extrovert, but because collaboration stopped being optional. It became the only way forward. Robotics taught me something I can now carry into every part of life. People aren't obstacles to efficient systems. People are the systems. So, once I learned how to fail safely inside the robotics club, how to treat failure as feedback instead of personal indictment, something irreversible shifted. I started saying yes to things that used to terrify me. I joined debate, even though public speaking what made my stomach turn. I tried knitting with a group of people who welcomed me even when my scarves looked like tangled disasters. I played baseball for a season. It, I wasn't really good, but I learned how to be part of a team that wasn't made of programmers. And I baked goods every week for the local shelter and discovered that showing up consistently matters more than being perfect. Through friends, I dipped into music, animation, even storytelling, nights where I read terrible first drafts out loud. I was never the best at any of these things, not even close, but that stopped mattering. Every new experience added a new joint, a new sensor, and new degree to my freedom of personal system. Every moment of discomfort made the next one a little easier to face. Growth stopped feeling like something dangerous I had to avoid. It started feeling like something natural I could expect. When my family moved back to Houston few years later, I faced another problem. The classes were faster, more competitive, and more STEM heavy. I had gaps in my knowledge from the different curriculum. The social scene had moved on without me. But this time I didn't retreat. I had to learn how to fix myself. I reached out. I asked for help, and I treated this discomfort like loose wire, something to find and fix, not something to fear. Today, I'm still deeply involved in robotics. I still fail regularly, and I still fix myself constantly. But I also discovered entirely new passions, like ultimate frisbee, for example, simply because I'm now willing to show up before I feel ready. I no longer wait for confidence to arrive before I begin. I let the process of showing up, failing, adjusting, and showing up again build the confidence for me. Robotics taught me that systems never improve inside comfort zones. They improve through repeated testing, honest failure, and deliberate rebuilding. You don't have to move to another country. and you don't have to build a single robot, but you do have to be willing to step into environments that don't yet fit you, environments that will expose every loose wire you've been ignoring. So here's the question I leave you with. If your life is a system, and it is, what part of it are you secretly afraid to take apart, knowing deep down it just might make you become stronger than before? So
Okay. Thank you so much for that talk. Really consider different elements. I like how you talked about your personal experiences with robotics, going obviously from stage to stage, and then eventually the troubles of moving from different countries and what that brought along with it, especially socially. So,
Yeah, and I think your experience with robotics also showed with that talk. It was very prevalent, and I could really understand all your knowledge really oozing in. But we have some questions through the chat right now. So, Kavin, if you want to start with the first one.
so first we have from Ethan. You talked about your background, but how did you actually get into robotics?
well, so robotics was always a club in my elementary school, and I sort of kind of let my parents kind of push me towards finding a club, and I went a few times, but I never really went inside to competitions, and because I was afraid of putting myself in on the spot. But once I moved to Canada, I realized how much fun and how much activity I actually had to put while going into competitions, and I sort of just embraced it, really.
For sure, for sure. I think that's a good
Yeah.
point. A lot of activities start as a hobby and then eventually grow into something that you really take further and take farther.
Yeah,
So,
so I think Stephen Navarro has a question now. It's how do you integrate machine learning into your robotics projects?
Uh, so I'm personally not integrating machine learning into my robotics project right now, but if as I'm working with robots, I kind of machine learning. Uh, sorry. So I'm not. Sorry. I So in my robotics projects, I'm doing VEX and other robot tournaments right now, and it's not really machine learning, but machine learning is a big part, and machine learning is a big part in robots after high school and college. As you go into college, I'm not integrating it right now in VEX right now.
Oh, okay. Kavin, next question.
so next up is, I think, a follow up from Steven. Also, what trends do you think you will see in 10 years or maybe 5 years' time as well? Because there's still a lot of changes to be there in terms of AI and robotics.
So, as of right now, we are already seeing a lot of AI in robotics. Even while making our own robots in our competitions, we are still integrating AI, maybe for design help, or help to help for code or code fixing. We're seeing a lot of AI into it, and I think in 10 years AI will help. It won't take over jobs of people, but it will help us quite a bit, and will become a really big impact. Will have a really big impact in the world of robotics.
Yeah, so I think
Okay, for sure.
the next question's from Multier, and it's asking what real world problems are you most excited to solve using robotics and machine learning?
So some real world problems I think that might help a lot. Uh, Robotics might help a lot with is I guess using robots um, to help uh, fix and not replace, but help with human labor that is hard for humans themselves. So if we use robots to help with human labor, dangerous human labor like mining or um, stuff like
Space
that.
travel, right?
Yes, space travel is a very
Yeah.
good example. It might it might make it less dangerous for humans overall and will help a lot of people.
Yeah. So I think 2 more questions left. Kavin, if we could just get to the next one. Kavin, I think your mic is.
Sorry. The next one's from InspireX. How can autonomous robots maintain accurate localization and stability in unpredictable high noise environments using real-time sensor fusion? I think it has a bit of
Yeah.
obviously a bit more technical and talks about just probably geospatial mapping, I think.
Yeah. Like GIS mapping, I'm pretty sure.
Krish, are you able to hear us?
Yeah. Did you get the question?
Oh, he might have disconnected.
Yeah.
Um,
Krish, are you there?
we can wait a few minutes, I think, for him to come back. I think his network might have gone out like the others, maybe.
Yeah, perhaps.
Okay. In the meantime, at least let me confirm with the next speaker.
Yeah, I'm gonna confirm as well.
I'm gonna see if I can message him then.
Yeah, let's contact him.
Okay. If I think by maybe 3:10 or 3. Okay.
Yeah, he's back.
Wait.
Yeah.
Can you hear me?
Yeah. we
Yes.
can-
Are you able to hear us?
Yeah.
Yes. Sorry there. My
Yeah, no
internet gave out. Okay. So what was the question?
It was. Yeah, you can read it, Kavin.
Okay. It was from InspireX. How can autonomous robots maintain accurate localization and stability in unpredictable high noise environments using real-time sensor fusion?
Okay, so autonomous robots use multiple sensors like LiDAR, and, cameras, and IMUs to understand their surroundings and track their position indoors. They combine this data using algorithms such as LAM to up their location in real time. So to stay stable, robots use feedback control systems that quickly adjust their movements when their environment changes.
Oh, okay. I think that was a pretty good answer. I think LiDAR systems really help in like high noise environments, like especially if you're in an environment like deep space, for example, there's gonna be like a lot of noise, and I think your answer really depicts that level of interference that can come with the sensor fusion. But we have one last question from Nathan Matthew right here. So Nathan's asking, how can reinforcement learning be effectively integrated with kinematic and dynamic constraints to optimize multi-agent robotic coordination in real-time unstructured environments? It's a bit of a mouthful, but we'll give you a couple seconds to answer. Oh, one second. Kaveen, I have some like difficulties with my camera, so I'm gonna fix that real quick. Is that fine? Yeah, I think your mic is muted, Kaveen.
I was gonna say I can see your camera fine, but if it's
Yeah, I'm gonna turn it off for a little bit and try to troubleshoot real quick because I think it's
okay,
turning on and
okay.
off.
So, can you hear me?
Yes, we can hear you.
Sorry. So, Nathan, that's a great question. So reinforcement learning can be integrated with kinematic and dynamic constraints by designing the reward function and action space to follow the robot's physical limits. The learning algorithm can use the real-time feedback to adjust movements while ensuring they stay within safe speed, force, and motion boundaries. This allows multiple robots to coordinate efficiently in unpredictable environments without violating mechanical constraints.
Okay, amazing. And I was just gonna say, obviously, I like how your talk. Obviously, great job answering the questions. There were some hard questions, very specific, very technical. And
Oh wait, Kaveen,
obviously, as a
yeah.
student, oh,
Yeah, I think
Here's
we have
one.
another question. Yeah.
okay.
So from InspireX to 2934, how can multi-robot systems adapt in real time to unpredictable environments while respecting dynamics and actuator limits? So judging from like InspireX's question, I think he really wants to know like how it would fare in like environments where like where it's difficult for robots to survive.
That's a pretty good question. So multi-robot systems adapt in real time by using sensors
Yeah,
using sensors to consistently monitor their environment and share information with each other. So control algorithms adjust each other's speed and movement based on dynamic and actuator limits to prevent overload or instability. This coordination allows the team to respond to unexpected changes while uh, staying within safe mechanical boundaries.
Yeah, okay. I think that's a great answer to the question. I think it really encompasses the entire scale of the question. And I think you probably had one of the hardest questioning blocks so far because obviously the chat got really technical into it. But thank you for diligently answering. I think those were all great answers. And I think your technical depth really did shine through with the aptitude that you were able to answer the questions through. So thank you.
Yes. Yeah, that was I think very good. I like how you really did convey once again how your social and I'll just say struggles moving from one country to another and what you had to deal with and pushing past and being able to, of course, win that accomplishment. I forgot exactly what it was, but at the provincial level was amazing. And of course, being involved in clubs, being involved in AI. So yeah, I think that's great. I think InspireX is definitely technical, probably definitely in robotics and definitely very involved. I can see that. So yeah, great job there. Those are some tough questions and good job, Krish, for answering them well. Thank you so much for giving your talk.
All right, thank you for your time.
Yeah, thank you.
There is always an opportunity to contribute to the discussions that we have at EnviroCast Geo. If you are interested in attending or even speaking at a future conference, learn more at geo.envirocast.org. We're excited to hear your insights.